Good afternoon, students who are working on your own. If you're tuning in, well, good morning, good afternoon, good evening. I don't know when it is you're watching, but today we're going to finish up section 5.12. The section's known as energy levels. We did start it on Friday, and we went ahead and we used Pear Deck to discuss all of this information. Now, I am working with eighth period today. I kind of forgot to do it during fifth period. So we're going to do a quick review of each section and then we're going to finish up the lecture. Okay? So this is a continuation from Friday's video. All right, so here you have 5.12 energy levels, and the first thing that we talked about was the introduction using fireworks, and we discussed how the different colors are due to, electrons or atoms getting hit with a large amount of energy, causing electrons to jump to higher energy levels. And it'll stay there, it'll orbit around the nucleus for a certain amount of time, and eventually it has to return to its original energy level. And when it does, all of that energy that got absorbed will be released in the form of light. Different elements have different arrangements of electrons, and that is what causes these different colors of light to be seen. So today is all about energy levels, and the first thing that we discussed on Friday is what is an energy level. We said another name for energy level is electron shell, and the definition is that it is a fixed distance. It's an energy level are fixed distances from the nucleus of an atom where electrons may be found. Remember, electrons can be in one energy level or another, but they cannot be in between. We talked about the electrons in energy level 1 having the least amount of energy. And as you go further from the nucleus, as you go further and further from the nucleus in these higher energy levels, electrons will have an increase in their energy. Okay. And it is an increase in a fixed discrete amount. They just don't talk in terms of how much energy. When electrons absorb energy, they jump to a higher energy level. They'll orbit for a little bit, and eventually they'll have to return to its original energy level. It will release the energy it gained in the form of light. Okay, and we talked about the first four energy levels. We talked about the maximum number of electrons, and you can see here that each energy level has a different number of electrons in each, right? If you're talking about the first energy level, you can only have a maximum of 2 electrons. In the second energy level, you can only have a maximum of 8 electrons. In the third energy level, you have a maximum of 18 electrons. And in the fourth energy level, you have a maximum of 32. These energy levels also have letter names. You have energy level K, L, M, and N. And then we started talking about energy levels and orbitals. And we talked about an orbital is a volume of space within an atom where an electron is most likely to be found. And we talked about 2 types of orbitals. We talked about the s orbital. We talked about the p orbital. We said s orbitals have a sphere-like orientation. A p orbital looks like a figure 8 or an infinity sign. Or some people say that they look like dumbbells. I don't know. It just depends on what you see. Either way, one orbital can hold a maximum of 2 electrons in each orbital. Okay. The last major topic that we talked about is the outermost energy level. In this outermost energy level, it has a very special significance because this is the location where you have your valence electrons. Remember, valence electrons is the electrons that are available to be lost, gained, or shared. In order for an atom to be considered stable, it has to have a complete and full outermost energy level. And they talked about the example of helium. Helium will have 2 electrons in the first energy level. That's the maximum amount that level can hold. And therefore, helium will be considered stable and is very unlikely to react with other atoms. We then talked about 2 different elements from 2 different groups. We talked about fluorine, we talked about lithium. We said fluorine was an element from group 17. It will have 7 valence electrons. So for if you are looking at your fluorine atom, it's going to have 2 energy levels. The first energy level will be complete. It will have 2 electrons. The second energy level should technically have 8 to be stable. But in the case of group 17 and fluorine, it will only have 7. In the case of lithium, which is a group 1 element, it will also have 2 energy levels, a maxed out energy level 1, and energy level 2 will only have 1. So the best thing for these 2 elements, in the case of lithium, it probably wants to donate this 1 electron to probably fluorine so that fluorine can have 8. Lithium's energy level 2 will disappear. You will end up having energy level number 1 remain. It's maxed out, which is what you need. So both elements will be considered stable. And this is what it will look like. Lithium will donate that 1 electron, complete energy level number 2 with 8 for fluorine, making it stable. And like we said, energy level number 1 will remain for lithium. And of course, it's maxed out, so it's stable as well. And everybody's happy. Before we get to the summary, I want to watch this video that's got some very useful information, guys. I'm going to be stopping it to just, make some quick points and just, point out some very important information. All right.
Video about energy levels, sublevels, and orbitals, all parts of the atom, and about how electrons are involved in these parts and where we can locate them. So the whole point of this video is this chapter focuses on electrons. Where are the electrons in an atom? That's what we're going to get at in this video and start. So let's first refresh our memory and take a look at hydrogen. So if you remember, hydrogen has an atomic number of 1, and let's just remember from first semester that the atomic number is the number of protons, and if the atom is...
So remember, all of this information that she's talking about, of course, comes from the periodic table. And you have to remember that the atomic number, which is the number on top of the symbol, indicates the atomic number. Okay, guys? And if you know the atomic number, you know the number of protons. And if you know the number of protons, you know the number of electrons. And that's what she's going to be doing. She's going to be sketching this atom and the different energy levels and how many electrons are in each. Okay, so let's take a listen.
It's neutral. Then we know our protons are equal to our electrons. That's what a neutral atom is. There's no leftover charge. So if hydrogen has 1 proton, then it has 1 electron, and we'll assume it's neutral. So it's this 1 electron. That's what we want to focus on. Where in the atom is this 1 electron? And that's what the point of the video is. So I have drawn the hydrogen atom for you, and hydrogen has 1 energy level. We'll learn later on in this video how to figure out how many energy levels. We can also call this energy level a shell. So this is the first energy level. It's the closest to the nucleus. It's also called ground state. The first energy level, and only the first, is the exception. It can hold up to 2 electrons, meaning it can hold less than that, but no more than 2. Every other energy level from there on out can hold up to 8. So if my hydrogen only has 1 electron, then let's go ahead and fill this in. Here's the 1 electron. Okay, I'm going to use little dots to represent electrons. So for the sake of argument, we're going to put an electron either here, 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 here. We'll kind of see there's a little bit of a pattern that I use. So I'll put the first one up there. All right. Okay, let's take a look at another atom. How about carbon? Well, carbon has an atomic number of 6 on the periodic table. Again, we know that's the number of protons. And if carbon's neutral, those protons equal the electrons. And so we'll assume it's neutral. Therefore, 6 protons means 6 electrons. Again, our focus are the electrons. How do we fill the electrons in an atom? So, like we learned last example, the first energy level, or energy shell, or just we can even call it a shell, can only hold up to 2 electrons. So, 1, 2, top and bottom. Can it hold any more? No. Well, we said that there are 6 electrons. We just got rid of 2 of them, so there's 4 more left. The second energy level, and all the energy levels from there on out, can hold up to 8, no more than 8. It can hold less, but no more than 8. Again, we had 6, and we used up 2, which means there are 4 electrons left. So let's fill those in. 1, 2, notice my pattern, 3, 4. Again, total of 1, 2, 3, 4, 5, 6. So again, first energy level holding 2. The second energy can hold up to 8, but it's holding 6. Okay, that's great. Let's look at another example. Sodium. Sodium has an atomic number of 11, so we know it has 11 protons and 11 electrons if it's neutral, and we'll assume it is. Sodium has 1, 2, 3 energy levels. Again, you'll learn about the energy levels in a second. So I have 11 protons. Remember the rule. The first energy level can only hold up to 2. So there's 1, 2. The second one can hold up to 8. So 1, 2, 3, 4, 5, 6, 7, 8. Okay? All right, so that makes 10, right? 8 and 2 makes 10. I have 1 more electron. These are my total electrons. So I need to use an extra energy level to get that to now 11 electrons.
All right, so here you have your sodium atom, right? And what's going to happen, as you can see, that outermost energy level has only 1 valence electron. What do you think is going to happen, guys? If it's going to, is it going to gain 7 more electrons? What is most likely to happen so that this guy or this atom can become more stable? What do you think it's going to do? It's going to donate, right, Gael? It's going to donate because if you get rid of this 1 electron, well, that orbital that energy level is going to disappear, right? If this energy level disappears, well, you still have energy level number 2. And does it have the 8 electrons that you need to be considered a stable atom? Definitely, right? And you can even count them here. 1, 2, 3, 4, 5, 6, 7, 8. That's a maxed out energy level number 2. So if we donate this 1 electron, we are going to have this second energy level, and it's going to be maxed out. That's why it will interact with group 17. Very, very good.
Electrons. So if you count up all the black dots, a total of 11 electrons. Just a reminder, where are my valence electrons? Remember, the outermost energy level is where I found my valence electrons, and there's only 1 valence electron here on sodium. Okay? How about hydrogen's valence electrons? 1 valence electron in hydrogen. That's why they're in the same column. How about carbon? Ooh. Outermost energy level, 1, 2, 3, 4. That's
right. So in this case, what do you think is going to happen in the case of carbon? What is most likely to happen? Is it going to be losing the 4? Is it going to be gaining 4? What do you think? What's your opinion? I'm talking to my 8th period students. What do you think is going to happen for this element, carbon, who's in group 14? What do you think? Take a guess, guys. What do you think? I think it will lose 4, says Gael. Anybody else? Anybody else want to take a stab at this one? Well, it might lose 4, but what's another option in this case? What's another option? What can also happen, Gael, other than losing 4? It will gain not 2, but it will gain 4. Remember, the maximum number for electrons for energy level number 2 is 8 electrons, right? To be stable. So either it could lose the 4 or it could gain the 4. It just depends on who he's reacting with. Okay, it can go either way.
That's why carbon is in column 4 on the periodic table. Just a refresher. Okay, so now that we've seen how these electrons are filling in, let's go back to some of our terminology and refresh our memory. An energy level, as we just saw, has a sublevel within it, and within the sublevel there's an orbital. And again, I like to use this analogy, hopefully this is looking familiar, that an energy level represents the floors in a hotel. The sublevel represents rooms, and the orbitals represent the beds in the room. And remember, this is how we actually can find, or where we can find, electrons. So electrons are actually kind of like sleeping in the beds that are found in the room that are on the floor of a hotel. So kind of like, where can we find you? You are in a bed that is found in a room in the hotel floor. So let's take this analogy just one step further and look at this. Okay, so this represents.
So right now she's talking about these orbitals that we started talking about. We only started talking about S and P orbital, right? We did not go into those other 2 orbitals, which are the D and the F. And we said that an S orbital will look and will have a spherical-like orientation, while a P orbital will look like that infinity sign, right? That figure 8 that's laying down, or we even said dumbbells. There is a shape for the D and the F orbital, but that shape is much more complicated, and we'll try and probably go into that later this week. Okay. For now, I would consider this as a introduction, a preview of what's to come.
A piece of the pie, and if we think of an atom being a circle, and then I've just kind of cut out a piece of the circle, okay? And if you notice here, I have energy level 1, N is equal to energy level 2, 3, and 4. 1 is the smallest ring, and so it's very, very, very small. There's not a lot of room. The only sublevel that there is in energy level 1 is sublevel S. In energy level 2, there's sublevel S and sublevel P. In energy level 3, there's sublevel S, P, and D. And in energy level 4, there's sublevel S, P, D, and F. So now you know the names of our sublevels. They're actually just letters. Okay? All right. Now, in sublevel S, there's only 1 orbital. Sublevel S, 1 orbital. Sublevel S, 1 orbital. Sublevel S, 1 orbital. In sublevel P, there are 3 orbitals. Wow, that's a lot. 3 orbitals in P, 3 orbitals in P. In sublevel D, there's 5 orbitals. 5. And in sublevel F, which you notice doesn't happen often, there are 7 orbitals. Now, to help remind you about this, or help give you an analogy, here's the hotel that's back. You go to the first floor, which is our energy level, and you go to the room S, which is a sublevel, and you open that door, and there's 1 bed. 2 electrons can fit in 1 orbital, 1 bed. Now I go on to the second floor, and the second floor is even bigger, and there's more room. So I have room S and room P. In room S, always there's going to be one bed, so 2 electrons can fill in there. And in room P, there's always going to be 3 beds. So I got 2, 4, 6 total electrons can fit in there. Okay, and I go to the 3rd floor. There's even more room on the 3rd floor. There's room for room S, room P, and room D. Remember, room S always has 1 orbital. P always has 3, and now we see D always has 5. Look how many more electrons can fit in. Remember, each bed or orbital can hold up to 2 electrons. Now let's look up here on the 4th level. I have S, P, D, and F. We said S holds 1 bed, P holds 3, and D holds 5, and now F holds 7. So 2 electrons can fit here, 6, right? 2, 4, 6, 8, 10, and 14 electrons can be held in the F. And it keeps going on, but for our analogy right now, this is good enough. Okay. All right. So with that being said, there's actually a way you can arrange the periodic table, or the periodic table is already arranged, that can help you out with our sublevels. This is really good to sketch down. This section of the periodic table, the first 2 columns, are the S sublevels. The middle transitional metals happen to be the D, and the elements to the right, which are mostly nonmetals, but some of the metals, are the P. We call these the SDP block. Down below, the actinides and lanthanides are the F.
All right, so that's just a preview of what's to come in the coming week, okay? So let's summarize today's topic. The first bullet point says energy levels, also called electron shells, are fixed distances from the nucleus of an atom and where electrons can be found. As you go farther from the nucleus, electrons at higher energy levels will have more energy. Bullet point 2, electrons are always added to the lowest energy level first until it has the maximum number of electrons possible, and then electrons are added to the next higher energy level until that level is full, and so on. The maximum number of electrons at a given energy level depends on its number of orbitals. There are at most 2 electrons per orbital. And the last bullet point says electrons in the outermost energy level of an atom are called valence electrons. They determine many of the properties of an atom, including how reactive it can be. These are your review questions. I did eliminate question number 5. It is not part of your review questions. Number 1 says, what are energy levels? Number 2 says, relate energy levels to the amount of energy their electrons have. 3, what must happen for an electron to jump to a different energy level? Number 4, how many electrons can the 4th energy level have? And how many orbitals are there at this energy level? All right.